Hey guys, thanks for tuning in. So in this tutorial, we will look at how to generate flowers from curves using geometry nodes. We'll build a node system with which you can just draw the outline of flowers, the leaves, the stems, and get a 3D flower mesh in the end. We will also build a few parameters so that you can tweak attributes like number of petals, leaves, their width, their noise displacement in real time. So we'll split this tutorial into two parts. In part 1, we will focus on generating the base mesh for the flower. In part 2, we will apply the chaotic magic that is noise onto the mesh to bring some life into it, and we'll also look at making some nice animation and material for it. There are lots of flower geometry node tutorials out there, but this one, dare I say, is one of the most procedural and parametric because we literally generate everything from math. It is extremely quick and flexible. You can shape your flower in the exact way that you want and keep tweaking it until your heart is content. So buckle up for some vector math, a lot of curves, and let's dive in. Okay, so we will mostly be looking at the XY plane into the Z-axis. I'm using Blender 3.6.1, but anything from the last few months should work. First, let's look at how Blender stores Bezier curves, because we'll be talking about this so much, you'll get a headache whenever I mention curves again. The smallest unit of a Bezier curve is a Bezier segment. It has a starting point, it has an end point. The starting point has a handle that specifies its outgoing direction, and the end point also has a handle that specifies its incoming direction. So if you open the spreadsheet tab and look at the spreadsheet data for a sec, and you'll see that we currently have one spline with two control points, the start and the end. So if we get rid of that spline and draw a more complicated spline, you'll see that we still have one spline, but it has more control points. And if we look at these control points, they all have handle left and handle right stored with them. These are the in and out handles for those control points. Now, if we draw a second spline, we'll have two splines within the same curve object, and at the same time, we'll also have more control points. Each spline will remember which control points it stores. Alright, let's draw three curves. So let's draw one for the outline of the flowers. Shift D, duplicate, delete the vertices, and then draw one for the outline of the leaves. And finally, duplicate, delete vertices again, and draw one for the stem. Let's drop in a mesh and create a geo node on top of it, name it flower gen. We're gonna drop the three nodes. Let's rename them first. This one is flower curve, leaf curve, stem curve. Alright, so let's drop the three curves into the geometry node. Make sure to select relative on the object info node so that you always get the world position of the curves. Let's start by resampling the flower curve. Drop in a resample curve node. Make the count a group input. Let's call the input petal count, because this parameter is going to control how many petals we'll generate. By the way, I'm using the Node Wrangler plugin. This allows me to just Command-Shift, click on any node, and then preview its output in the viewport, which is really neat. Alright, let's instance a bunch of curves onto the points. Drop in a instance on points. We're gonna feed a Bezier segment as the instance. And you can see a bunch of Bezier curves appearing, but we're not gonna use any of the default points, so let's set all the points to 0, 0, 0 for now. Now they all disappear because they become zero length curves. Let's use a realized instance nodes to turn the instances into real geometries. Now you can see there are 7 splines that each have 2 control points, and the control points are positioned around the flower curve. Now, we're gonna select half of these points and then position them at the center of the flower so that we will have a bunch of curves radiating from the center. The general idea is that we're gonna sweep another profile curve along these lines so that we get the petal geometry mesh. So I'm gonna use the set position node. And since I only want to select half of the points, I'm gonna use selection and use a modulo node here, feed in the ID of the control point and modulo it by 2. Now I'm gonna use a compare equal node to select the points that modulo to 0. Now, how do we get the center of the flower? Well, we can define it as one of the endpoints of the stem curve. So to get that position, we're going to connect position to a sample curve node. We're going to connect that to the stem curve geometry and connect the position to position. As you can see, if we move the factor, it's going to give me the position for points along different factor of that curve. We're just going to leave it at 0 for now. Let's use a curve to mesh. And for the profile curve, we're going to supply another curve line that goes from -1, 0, 0, 0 to 1, 0, 0. Let's go to Object tab, Viewport Display, and enable wireframe so that we can actually see the wireframe of the geometry. Let's also take a look at why the lighting is kind of weird. Oh, turns out I just have this random value plugged into the viewer. Let's unplug that. Alright, it's starting to look like a flower, but let's make the petal look nicer. Drop in a set radius node so that we can control the width of the profile curve. We're gonna feed the radius to a float curve, feed a spline factor field to the value of float curve. What is a spline factor, you might ask? Well, it's basically a fraction that progresses from 0 to 1 for every point along the curve. So for the point in the beginning, it has fraction 0, and then for the one in the end, it has fraction 1. Now, let's try to control the shape of the petal with this float curve. There's an issue though, which is we don't have enough geometries on the curve. It only has 2 points, so when both of their radius become 0, it just disappears. So let's give it a little more resolution by dropping another resample curve in front of the set curve radius node. Now every petal curve have 10 points on it. And we can sculpt it however we like by inserting more points. You can get really elaborate if you want, but for now I'm just gonna leave it simple. So our geometry is starting to look like a flower, but when you increase the petal count, it's looking kind of dead. It's super artificial. Several reasons. First of all, it's quite literally falling flat. It's super flat. Let's think about how we can fix it to make it more three-dimensional. Well, an obvious thing to do is to just lift the curves up into the z-axis. Let's connect our nodes to the group output, and now the petals have the shape of a cone. This is looking okay, but it's still a bit unnatural, because if you look at the petals, they're all perfectly aligned on the outline curve. Plants don't quite do that in nature, especially when they have a lot of petals and leaves that they want to spread out evenly. So commonly, they follow this pattern, which according to Wikipedia is called a Phyllotaxis spiral. In this spiral, each petal scales down a little bit as it approaches the center of the flower. Every 2 petals are also separated by a fixed angle. And for maximum spread, the golden angle to use here is the magical 137.5 degrees. Pretty cool, right? Let's build it out. Well, first, let's do a few cleanups. Let's select the nodes that we use for extruding the petals and put them into a group node, and let's call it extrude petals. Also, let's disconnect it for now so that we can get a better look at just the central curves. Let's move our nodes around a bit to give us more space to work with. And these 2 nodes over here for sampling the flower center are going to become very useful later. So let's put a frame around them before we forget and call it flower center. To form the big spiral, we need 2 types of translation for each petal, scaling and rotation. To get the scaling, let's go to our original flower curve right after the resample curve, drop in a set position, and then connect it to a mix node. We will be mixing between the center of the flower, which we have already computed, and then mix that between the original point position. For the factor of the mix, we will drop in a spline factor field. And there, the petal curves are already looking spirally. For rotation, if we ignore the curve for a sec and just imagine an abstract loop that goes from 0 to 360, the first petal would start at 0, and then the second petal would be at 137.5 degree, the third would be at 137.5 times 2, and basically the nth point would be at 137.5 times n minus 1. To take the curve into consideration, we're going to do an approximation. It's not a perfect loop, but we're going to pretend at fraction 0 is at 0 degree, and then at fraction 1, which is the endpoint, is at 360 degrees. Well, for the first petal, we can simply put it at fraction 0. Where should the second petal go? Well, we can simply advance it by a fraction that roughly maps to 137.5 degrees. That means the fractional increment is going to be 137.5 over 360, which is about 0.38. Now for the next petal and the next petal, we keep repeating the same thing, which is incrementing the fraction by 0.38. And what happens when the fraction goes over 1? Well, we can simply modulo it by 1, which is basically taking the fraction. This way the points will go around the loop forever. Okay, so previously we were mixing between the center and the position. So let's get rid of the position. Drop in a ID node. Use a multiply node so that each increment is 0.38 apart. And we will take the fraction so that it doesn't go over 1. And then we're going to feed this to a sample curve node. So this will be the sampling fraction. The curve is the flower curve itself. And we will feed the position to the input of the mix. And voila, you see here the distribution is a lot more spread out. And if I increase the petal count, it's kind of looking like the distribution of a flower petal. You may notice that the smallest petal is really small. It always goes all the way to the very center. So if you don't want it to zoom in that much, what we can do is we can plug in another mix node. Plug in this result and then plug in the position that would be if there were no scale effect. And then feed the new result to the position. When the factor is 1, there's no zooming in, but when it's 0, it's fully zoomed in. This is kind of an important parameter for the shape of the flower, so let's make this a group input. And I'm just going to call it petal inset. Great. Alright, so if we connect the extrude petal, it's looking more interesting. I promise you that the spiral is gonna look a lot better when we fix the other half of the problem, which is our petals are still super duper flat. If you look at them from the side view, the petal curves are straight lines. They look like this. Remember, these curves are Bezier curves, so we can bend them with handles. If we move their handles in a direction that is perpendicularly pointing away from the main curve direction, the final curves might bend like this. How do we compute the position of this handle? Well, we're going to use a little bit of vector math. So, for each petal, we already have a direction from the center of the flower to the endpoint. We can call this dir. And we also have the tangent of this point on the original flower outline curve. So these are a bunch of tangents along the curve, right? So we can call this t. So if we do a cross product between t and direction, we're going to get a third vector that is perpendicular from the two. And that will be the direction that we move our handles in. Alright, let's do this. Let's get rid of the viewer node for now and go back to the very beginning. Look at the flower input curve right after the resample. The tangent is easy to get because we have already computed it. Remember the sample curve node that we used earlier when we formed the big spiral? Well, if we just drop down a store named attribute, change the type to vector, we can simply plug in the tangent that we have sampled from this spiral as the value of the attribute. Let's call this attribute tangent. Next, let's compute the direction from center to petal tip. If we look at this realized instance node, the point at this point are already at the tip of the petals. You can't see them because all the curves have 0 length, but we can visualize it by dropping a instance on points and then feed an icosphere as the instance. Let's make the icosphere smaller, and voila, the points are following the layout pattern. Let's add a store named attribute right after the realized instance, and we will be storing a vector with each point by the name of dir. And for this vector, we are actually gonna drop in a subtract to subtract the position of the current point from the center of the flower. We'll also use a normalize node so that this direction is normalized. A quick note here, I actually want the resample curve here to go into the extrude petal node group because it's a preparation for the extrude. So let's just quickly put it into that node group. Now let's move the Bezier handles. Drop in a store named attribute. We will set a vector on a point attribute that already exists called handle right. And voila, already the curves are bending, all towards 0, 0, 0 because we haven't set a value yet. To bend the other side of the handle, simply duplicate the store named attribute and change the field name from handle right to handle left. So I always have trouble remembering what's handle right and what is handle left, which is ingoing, which is outgoing. So my way for figuring it out is I will connect the value to a position. Same for the other one as well. I'm gonna offset this position by using a vector math add. I'm gonna add the position with a little offset. Let's just do a X offset. And now, as you can see, it's very obvious the handle right is for the endpoints, right? Because it's shaking the most. So now we know the handle left is for the center points. All right, let's compute the actual handle offset. Drop in a cross product, connect it to the add. We're going to feed it two named attributes that we just computed, one called dir, the other one called tangent. Let's also drop in a normalized node to make sure that everything is normalized. And voila, as you can see, it's working. Our petals are bending. A few things to tweak. First of all, I think it would look better if the bend amount scales with the length of the petal. To get the distance from the center of the flower to each tip, let's go to dir, duplicate it, change the name to distance, change the type to float, and then we can feed it the length of the vector that goes from the center to the tip. Going back to where we set the handles, now here, right after the normalize, we can drop a multiply. Actually, let's drop a scale node and feed it the named attribute called distance. Let's connect the scale to the add. We can do a scale again after the scale. And this scale is kind of like a bendiness control. So let's expose this as a group input. And we'll call this petal bend. Perfect. Now let's set the handle position for handle right. I believe this entire network of nodes over here can directly be reused. So let's just feed this add node, which is what we feed for handle right, to handle left as well. Yay, seems like it's working correctly. Alright, now if we control the extrude petal, voila! This is looking a lot better. We can change freely the number of petal count. Woohoo! We can also change the petal bendiness easily. We can even have it bend the wrong way, the opposite way. I'm just gonna give it a little bit of bend. We can control how much it zooms towards the center. And the awesomeness of this approach is it's fully non-destructive, fully procedural. So when you move the stem, flower center moves with you. You can even move it outside the flower, which I think produces some of the more interesting results. Because when this happens, if you look at the side view of the flower petals, some of them are actually bending upwards. Some of them are bending downwards, thanks to the vector math that we did just now. So you get some nice occlusion results. There's still one quick thing that we can fix. Right now, there's not enough resolution across the horizontal direction of the petal. Let's fix that. Let's go to the extrude petal. Here we're just sweeping a curve line. That's probably only 2 points, right? So we can drop in a resample curve node. Here I'm gonna change the mode to length so that I can resample by the segment length. And I'm gonna promote the length parameter to a group level input so that we can tweak it from one level up. Let's call it resample length. It's already looking a lot better with more geometry. We can even make the resample length an input of the entire node group. And we can use the same length to resample the direction that goes from the center to the tip. let's look at where that resample should happen. Aha! I think it should also happen within this extrude petal node group. Let's dive into that node group, find the first resample curve, change the mode to length, and plug in the same resample length. And sweet! Now you have resolution control in both directions in the petal. Now let me show you more fun parameters to tweak. Remember this flow curve node that we used to define the shape of the petal? Well, if we just plug another multiply after it, feed the result to set radius. Let's make the other input to multiply a group input and call it petal width. Let's go one level up and make the petal width a geonode input. Now you have a control for, well, the width of the petal. Control H to hide the unused input. Now let's annotate our graph before it gets too crazy. This whole section here is for endpoint layouts. Well, petal endpoint layouts to be specific. Well, these three guys over here, they instance a bunch of Bezier segments that are zero length onto a bunch of points. So let's put them into a group node and call them instance zero curves. Now, all of the rest of the nodes here are really for positioning the Bezier control points and Bezier handles. So let's put them into a frame and call it position Bezier curves. And these last few guys are for extrusion. Great. Alright, I think we're done with the flower petals for now. Let's move on to the stem. And the stem is actually quite easy to make. So we already have the stem curve here. Let's connect it to a curved 2 mesh. And as for the profile curve, let's connect it to a curved circle. Now we have a tube. Now let's work on the shape of the stem a little bit. Let's drop in a flow curve and connect its value to, you guessed it, spline factor. And let's just play with the curve here until we get something we like. Alright, I think I'm pretty happy with this shape where there are 2 bumps on the end. Every time a curve extrusion disappears after you tweak its radius, it might be because you don't have enough points on that curve. To fix it, drop in a resample curve node. Let's resample with the length this time, and let's keep tweaking the curve a little bit. And okay, I'm okay with it. So this section of the graph is actually quite a reusable operation. So let's throw them into a node group and call it extrude stem. To join the stem with the flower petals, drop in a join geometry and connect the stem geometry with the petal geometry, and voila, here's a full flower. I'm just gonna turn off the wireframes for now because they're getting a little distracting. And yeah, we're getting there. Alright, now let's move on to the leaves. Well, first thing first, I changed the leaf curve a little bit so that now instead of going around the whole stem, it's only staying on one side. So the plan of the leaves are gonna be very similar to the petals. We're gonna instance a bunch of curves and set their endpoints so that they go from the leaf curve to the stem curve, like this. Alright, let's start with the resample node here. Again, let's make the count a group input and call the input leaf count. Now, to instance a bunch of curves, we're gonna use instance zero curves node that we just created. Remember, this is what we use to instance the flower curves. You can't see anything, but you can visualize by dropping a instance on points node, feed a icosphere as the instance. Yep, they're actually all on the leaf curve. Since these 2 nodes are really useful for visualizing, why don't we just put them into a group node and call them visualize points. Alright, now we have a bunch of splines with exactly 2 endpoints. Let's use again a set position node. And for selection, we will use a modulo and a ID field. So we'll modulo the ID by 2. And if the result is equal to 0, we're comparing 2 ints here, we select the point. Let's get rid of this visualizer. So as for the position, we want to sample the position from the stem curve. So let's drop in a sample curve node and connect the curve input to the stem curve here. Connect the position output to the position here. For the factor input, we actually want to sample with the factor of the starting curve, which is the leaf curve. So we have that factor actually here, right after the resample curve node. So we're gonna use a capture attribute node here, connect the value to a spline parameter, and then we will feed the output to the factor. Voila! A bunch of curves going between the leaf curve and the stem curve. Now, let's introduce some bendiness to these curves so that they don't look so mechanical. Well, as you might have guessed, we can again move the Bezier handles so that they point in the tangent direction of the end curves. So we will drop a store named attribute node. We'll set a vector on handle left. And immediately there's bendiness, but they're all pointing towards 0, 0. So instead of 0, 0, 0, let's use a add, and let's add between the original point position and the tangent of that point along the curve. So it's tempting to directly connect a curve tangent, but that won't work because this tangent value, when we use it here, will actually be the tangent value of this small curve segment. So they will actually be pointing like this. But the tangent we want to use is the tangent along the outline curves. So we need to get that with a sample curve node. Fortunately, there's already a sample curve node here. It's sampling the tangent of the stem curve. So let's just try to feed the tangent into the add here. And voila, already you can see it's bending in more of a reasonable direction. One issue here is we actually want to bend the other side of these curves with a stem tangent. So that means instead of handle left, we actually want handle right here. Voila, that's better. To bend the other side, we can simply duplicate this store named attribute. This time we will use handle left. And then for the position, same thing, we will use a vector math add node to add between the position and the tangent. So for the tangent, we'll use another sample curve node. This time we'll be sampling along the leaf curve. And for the sample factor here, we can use the same captured attribute here and feed it to factor. Let's feed the tangent to the add. Now we have bendiness on both sides. Alright, to build a little bit of control of how bendy we want these curves to be, we can simply add a scale node after the tangent. Let's make this scale factor a group input, and we will call this leaf bend. Now let's add the same thing to the other side. Connect the tangent to a scale and then feed the leaf bend to the scale. But now we have a little control, which is pretty sweet. Finally, let's connect a petal extrude node. This is what we used to extrude the petals earlier, right? And we can tweak the petal width however we want. Putting everything together, let's connect the extrude petal result to this drawing geometry. Voila, you have a flower with a bunch of leaves. So to get leaves on the other side, we can simply reuse this section of the network, accept another curve input, and then generate leaves for the other side. I'm gonna put all of this into a group. Let's name this group gen leaves. For the inputs, the first one connect to the leaf curve. We can call this leaf curve. The second one must be the stem curve. And then the scale is actually the bend scale. Let's move things around to make it look more readable. Let's duplicate it. I'm gonna duplicate the leaf curve, get rid of the points, and then draw it on the other side. Drop our second curve into the node tree, connect it to leaf curve, connect the stem to the stem curve. Voila, there's the other half, and we can just join the other half to the drawing geometry here. Now we have a full flower. If you don't want leaves generating all over the stem curve, there's an easy trick that you can do, which is to drop in a trim curve node onto the stem curve. And this is basically trimming the stem input that we feed to these two gen leaf nodes so that you only get leaves on a subsection of the stem curve. Alright, at this point, our node setup is basically complete. You can try to tweak the curves in the viewport, and everything should move as you move the curves. It's really quite sweet. I can even have a little flower open animation if I want, by animating the curve. If you want a second flower, just duplicate all the curves from the first flower, or create new ones, however you want, and change up the shape. let's add a mesh object and assign the gen flower geometry node to it. And now you can see a problem, which is all of our curves were previously hard-coded into the geometry node. To make them configurable, let's make all of these group inputs. Let's call this flower curve, stem curve, and same for here. All right, and then let's clear the default input on all of these inputs. Sweet. Alright, now for my second flower, let's select the other set of curves that I just drew. Well, make sure to always select relative, otherwise it will use some weird local position. Sweet. Now, one note is this setup should work pretty well when you have 3D curves. Now everything is in the XY plane, but if I move the curve up like this, it should all work pretty well. You can really position these curves however you want in 3D, like lifting this side of the leaf up, lifting this side of the leaf up, perhaps. For the sake of this tutorial, I will keep things mostly within the XY plane, but feel free to tweak it however you want in your own workflow. Alright, let's get rid of this flower for now, get rid of the unused curves. Some of you might wonder how to generate the filaments. Well, the process can be really similar to that of the petals. Essentially, you can take the petal outline curve and then generate a second curve that is roughly the same shape, but just closer to the flower center and more scaled down like this. And then you will probably also use a smaller width to generate the petals, and then as a result, you have a bunch of filaments that are petal-like. I will not go into detail about that flow because I think it's quite redundant. However, I want to show you something that's even cooler. So because we're quite literally generating everything with math, we have a lot of control on the exact shapes. For example, we go to the extrude petal on the flowers. So here we're fitting in the petal width directly. Instead of using a constant, we can actually make the width dynamic for each petal. So say if we have 10 petal curves in total, 1, 2, 3, 4, all the way to 10. I can specify it such that the 0th curve have the smallest width, and then the 10th petal has the max width. And everything in between either interpolates smoothly or follows some kind of float curve. So to do that, we'll need to compute the fraction for each petal to represent how far along they are to the flower center, starting from the edge, 0, and then going all the way to 1, which is at the very center. Let's drop in another store named attribute and feed it the spline factor parameter. Let's call this center factor. So this attribute will stay on the points, center factor. Let's just make sure that we don't lose it when we generate the geometry. So in the generated curve here, they still have a center factor, which is great. It's right here. All right. So for petal width, let's feed in a name attribute called center factor. And already, as you can see, they're getting a various width. And I'm gonna drop in a float curve node. And I can freely tweak the curve so that I have a custom mapping of the factor. Let's drop in another multiply node. Connect the input petal width to the other input, and then connect it to the petal width. This way, we can still use this slider here for petal width to control the overall multiplier for petal width. So I'm gonna increase the petal inside here so that they zoom inwards a lot. I'll create a lot more petals and just play around with the curve until I get something that I like. Yeah, I think this is quite nice. Everything is looking kind of nice. I want to give a little more geometry on my petals, so I'm gonna go to resample length and give it a smaller value. Voila, there you go. Alright friends, I'm gonna pause here and take a break because I really need to get a life. But part 2 is coming. There are so many more cool tricks that I want to share. To give you a preview, We'll be breathing life into the flower by introducing noise of different intensity levels literally everywhere, into the mesh, into the material, and maybe even into the animation. Alright, thank you for watching. Please like, comment, and subscribe for more tutorials in the future. I'll see you in the next one. Happy creating, and don't forget to save.